What up, YouTube? It's your girl, Tin again. I'm coming at you today with a partial fractions question. So, without further ado, let's jump right to it. Alright, so the question we're going to be solving today is the integral of 2x plus 1 divided by x squared minus 7x plus 12. Alright, but before we get started, let's talk about what a partial fraction question is. So basically when you see the integration sign, you're going to be doing something in reverse. So recall back when you were in maybe 3rd grade and you were learning about fractions. And your teacher put on the board 1/4 plus 1/2. How would we add these together? Yeah, we had to get them to have similar denominators, right? So of course we could say we'll multiply this top by 2 and this bottom by 2. And then we'll end up with 1/4 plus and then 2/4. And now since our denominators are the same, we could add them together and we end up with, not 2, 3/4, right? So when we look at this partial fraction question, it is this process, but in reverse. So we start off with this 3/4, which is this right here. Let's just say that's our fraction that we're starting off with. But we're working our way from 3/4 and we want to break it down into the 1/4 plus 1/2. And that's pretty much the idea behind partial fractions. But let's go ahead and relate it to this question that we're going to work on today. Alright, so one of the first things I ask myself when I'm approaching a partial fractions question is it in simplest form? When I look at the numerator, there's nothing more I can do to that. But if I look at the denominator, it looks like it can be broken down a little bit more, meaning it can be factored. So let's go ahead and factor out the denominator. And of course, when we're factoring, we want to take the last number, this number 12, and we want to find two multiples that when we add them together, we'll get -7, but when we multiply them, we will get 12. So what two factors of 12 will give me that? So factors of 12, we have 4 and 3. Now, if I make the 4 negative and the 3 negative, if I add those together, that gives me -7. Well, that's my middle term. And if I multiply them together, it gives me +12. Voila. So that's going to be the one we use. Those are going to be the factors that we use. So then this is going to be written as 2x plus 1 over x minus 3 times x minus 4. Alright, so now what we're going to do is we're going to take this whole fraction and we're going to write it over, but we're not going to put the integration symbol there because we don't need it right now while we're working out all the mathematics. We're going to put that on the left hand side of the equal sign. Now on the right hand side, we're going to take each factor and we're going to put it as a denominator. And then because both of these factors are linear factors, the only thing we have to put up top in the numerator is a constant. So we'll call that one A and we'll call this one B. Now linear factors, it could be x plus 4. It could also be x minus 1 squared. This is what we would call a repeated linear factor. If we had, let's say, a quadratic factor like x, let's say we have x squared plus 3x plus 1 as the denominator, or x squared plus 4, then in the numerator you would write something like ax plus b or cx plus d, just depending on how many terms you had. Alright, but since we have linear factors, we only have to put a constant up top, and that makes things nice and pretty. Alright, and so now what we're going to do is, like we said earlier, when we're trying to make our denominators the same, we're going to go ahead and multiply both sides of this equal sign by the entire denominator. So this side, we're going to multiply it by x minus 3 times x minus 4. And then this side as well gets multiplied by the same factors. Now notice when we multiply the left-hand side, when we multiply these factors by this, because these are in the numerator, these guys cancel out nice and pretty. So on the left-hand side, the only thing we're left with is 2x plus 1. And then on the right-hand side, when we multiply this a over x minus 3 times the x minus 3, x minus 4, well, the only ones that cancel out is the x minus 3's. So then we're going to be left with our a, and that's going to be times the x minus 4 term. And then we're going to have the same thing with our b. So when we multiply our b's, we're going to see that the x minus 4's cancel. So then we'll have b times x minus 3. So the next step is to solve for the constants a and b. And here's where you can get a little bit creative, because you're going to decide which x values you want to substitute in. Now, I always go with the ones that will eliminate at least one of the variables so that I can get one of the constants by itself. So what do I mean by that? I'm going to try to plug in a value for this one here that will cancel out this a term. So then I'll just be working with b, or I can start with something that will cancel out the b term. So then I'll just be working with a. So let's say I'm going to make at x equals positive 4. I'm going to substitute everywhere I see x, I'm going to substitute in the 4. So then my new equation is going to be 2, and instead of x, I'm going to put in my 4 plus 1, and I'm going to have that on the left hand side, and then I'm going to have my a term, and then instead of x minus 4, I'm going to say 4 minus 4. And then, of course, plus b times, and then instead of x is going to be 4, and then minus 3. Now, if you see here, 4 minus 4 goes away to 0. So this a term cancels out. Now on the left hand side, I'm going to have 2 times 4, which is 8 plus 1, so that's going to give me 9. And then on the right hand side, of course, we're just going to be left with b times 4 minus 3. 4 minus 3 is just 1, so 1 times b is just going to give me b. So b is going to be equal to 9. So I'm going to write that off to the side because that's going to be important later on. And now we're going to do the same thing so that we can solve for a. So this time I ask myself, what number can I plug in for x that will eliminate this b term? Well, I see right now that if I plug in 3 here, 3 minus 3, that's going to give me 0, so that's what I'm going to call x. So this time to solve for a, I'm going to say that x is equal to 3. So I'm going to go ahead and substitute that in on the left hand side. I'll have 2 times 3 plus 1. And then on the right hand side, I'm going to have, instead of x minus 4, it's going to be 3 minus 4. Plus b times 3 minus 3. And as we already said, that's going to go away to 0. So that term cancels out. And now I'm just going to do the arithmetic here. 2 times 3 is 6, plus 1 is going to give me 7. Over here, I'm going to have 3 minus 4, so that's going to be a negative 1. So that's going to leave me negative a, or negative 1a, for those of you who may need to see it. So then, of course, here, I'm just going to divide each side by my negative 1. And that's going to leave me with negative 7 is equal to a. Alright, so now I have my a is equal to negative 7, and I have my b is equal to 9. So now we're going to take those constants and we're going to plug them back into this expression here as an integral, an indefinite integral, and then we're going to solve. So let's go ahead and do that. Alright, so let's recall we have a over x minus 3 plus b over x minus 4. and a is negative 7 and b is 9. So this we're now going to integrate, and we're going to substitute in our values. So we're going to have the integral, and this time we're going to have negative 7 over x minus 3 plus 9 over x minus 4. And since we're integrating, we're going to put our dx there. Now, because both of these constants, are sitting over top of linear terms, these are simply just going to reduce down to the natural log of the x minus 3 plus the natural log of the x minus 4. But let's not forget about the constants. So the constants that are sitting up top, those also just go out front. So this is going to be negative 7 times the natural log of x minus 3 plus 9 times the natural log of x minus 4. And let's not forget our beautiful constant plus c. And this is our final answer. Alright, and let me just explain something really briefly. So keep in mind the natural log of u is equal to u over u prime. So if we take this one here, remember we can pull out the constant, the negative 7, so that's going to be out front. And then u in this case would just be x minus 3. And u prime, well, the derivative of x is just 1. The derivative of negative 3 is 0, so u prime is just going to be 1. So then our answer there would be negative 7, and then times the natural log of u. Now u is x minus 3, so we're going to put x minus 3 here. And then we could say divided by 1, but of course if we divide it by 1, we just end up with what's in the numerator. And if you see, this matches that. So that is how I got that. And the same for this part. So as always, thanks for watching. Again, if you have any questions, drop me a comment in the box below. Or if you have a question that you would like to see me work out for you, leave that there for me too. And I'll catch y'all next time. Peace.